You're listening to a PubHouse Network podcast for developers by developers. Welcome to PubHouse episode 100. Hey everyone, this is the 100th episode of our podcast, and is kind of fun because we are going to cover soup to nuts. You always hear about it. You might be working on it, but it's kind of fuzzy. We're going to be talking about the cloud. And like we were talking earlier, like Bob was saying, like it only took us how many episodes to get to the cloud?
Yeah, like 100. But you know what? We're here, and we're arriving just at the same time a lot of other developers are arriving and getting started in the cloud, or maybe you've been doing it for a little while. But we're here to share our experiences and like we were looking at our agenda for today, and it's like, man, like we're not going to cover all in one episode. So, what we're going to start you off with is a kind of an overview today. And then we're going to get a second episode where we're going to go in depth, where we're going to have, what you usually expect of us from PubHouse is code samples and demos and just really talk through, what you can do on these platforms with your Java knowledge and even kind of beyond that, some of the tools that go beyond Java and help you build out cloud environments for your clients or for your employer or for yourself.
Yeah. No. So for those who are tuning in for the first time, welcome aboard. My name is Freddie Guime. I'm one of the principal engineers at Expedia, author, speaker, Java champion, and I'm here with my usual co-host, Bob.
Hey, everybody. My name is Bob Paulin. I'm an independent consultant from Chicago. I am the CJUG board chair, Apache Software Foundation member, also a speaker, and excited to be here with you all today talking about the cloud.
Right. So before we dive in, I wanted to thank the sponsor of our episode. Today's show is sponsored by Datadog, a monitoring and analytics platform that integrates with over 450 technologies, including AWS services, Docker, and Kubernetes. Datadog's platform brings together metrics, traces, and logs in one place so you can get full visibility into your environment and improve your application performance. With machine learning-based alerts, customizable dashboards, and distributed tracing, Datadog makes it easy to unify disparate data sources so you can troubleshoot faster. Start your free Datadog trial today. Listeners of this podcast will receive a free t-shirt once you install the agent and create one dashboard. Visit javapubhouse.com/Datadog to get started. Again, that URL is javapubhouse.com/Datadog. And we thank them for being the sponsor of this episode, for keeping the mics on and the beers rolling and the video recording. So thanks, Datadog, for sponsoring this episode. All right, so let's dive into it. And I guess the first part is understanding, we started with the cloud. When was it? 10 years? Was it 10 years ago?
I think it's actually been longer than that. I mean, AWS has been around for 10 plus years. I'd actually have to Google, when it started. Let's see. So AWS has launched 2006. So this is almost 15 years.
15 years
that we've had the cloud on AWS. And even before then, there was cloud. There was other cloud type things. But as we understand today, I guess what you would call the modern cloud. I think it's fair to say, that started with what AWS started stubbing out in 2006.
Right.
Where it's now a kind of a one-stop shop for everything that you want to do with your development environment. Basically the pitch now is you can host your entire infrastructure in the cloud. It used to be you'd go into a project, you'd have to tell somebody how many servers you needed. They would then place an order for those servers. the order would be placed. Eventually the equipment gets shipped. Then there's the OS installation process. Then there's hardening. And then at some point they turn it over to the development team with the level of access way too low to do anything. And then you need to install, all your software. Well, the days of that have sort of changed, right? So we've actually gone back in time in some sense to an environment where a lot of that is just sort of managed for you, which, for those of us that have been working long enough to remember, IBM DB2 mainframe environments where it's just like, it's there and it works.
Yeah,
that's sort of the first version of the cloud, so you're kind of dependent on a vendor that's providing you with a complete infrastructure environment that you can tap into, provision things, set things up, and then, you're not running it. They are.
And to add some color to that, like I still remember back in the day when you needed to plan for laying out a network, and it was like always the rule of thumb is like, whatever you ask for, double it, and then double it again. Because by the time everything is laid down, all the requirements come in, is going to be like, you were too short on the number of servers, you were too short on the number of networking, like provision IP addresses that you needed to get. Like it's always this, and the problem is like, because it is like capital investments, it's very hard to move that fast. Like every time you had to like buy a server, it will take you weeks before it actually make a difference in like what you were building, right? So in that sense, like we abhor decentralization. Like we sort of like, we like it when somebody is managing things for us, because that is one less headache that we have to suffer through. And I think that the interesting story was Amazon was trying to figure out how they automate these things, how they make it easier for their developers to create new things. And suddenly, they start creating all this infrastructure and all this management things. And they got some leftover capacity. That's how sort of like the story goes, that's how they started.
Right. E-commerce has always been, for a long time, actually, that's even changing now, has been focused around what they call Black Friday, right? Where everybody finally moves from the red into the black was how it was said, which is usually right around Thanksgiving. It's the Friday after Thanksgiving was traditionally what it was. And from a hardware standpoint, it was always a challenge running e-commerce and being like, you have to buy your hardware, scale your hardware to that one day of the year where you're going to get that wave of traffic, and you don't want to be taking downtime then, because you could be, depending on the scale of your business, losing millions of dollars every minute that you're down. It's an insane amount of traffic. It's an insane amount of money to be made. So Amazon had the same problem. They had to scale to that. And it's like, well, we have all this equipment sitting around for the rest of the year. What do we do with it?
Make a business.
Make a business out of it. So, that's how the story goes, as I understand it too. They figured out how to use that excess capacity and became very, very good at creating it so it could be self-service. I think that's been the biggest thing is mainframes, as much as, there is a good analogy there, it's certainly not as easy to use as what we work with today. In our cloud providers.
And I think that like, even if today, like you're using, one of the things is that even if today you're using the cloud, understanding the underpinnings, understanding exactly how things flow will make you such a much productive developer. Because one of the challenges that I always see, even when I was getting exposed to this, is that it almost feels like you're drowning on choice, right? Like if you ever open an AWS console, or if you open whatever Google console looks like, or Azure, you'll see like there's 100 kinds of services all screaming for your attention, and it's very hard to navigate, like understanding logically why would I want this? Why would I want that? And that's why, like, when we were talking with Bob today, like, oh, maybe we should split it in two and do like the first part is just conceptually get you there, what do you have all these parts of the infrastructure and how does it make sense on the cloud versus just having a server in your closet at the office that you work. This was, 15, 20 years ago, we just have like 4 servers in there and trying to hook it up together. How does that translate into running things in the cloud?
Yep. And we're going to kind of break this episode into a couple different parts because there's even though there's so many different things in the cloud, fundamentally, there's ways to categorize these things. And we're going to try to do that for you. So, I mean, we're going to start with what we will call, I guess, the core of it, which is determining, users, how you're actually going to authenticate and access your cloud environment, policies, just the security around, who can do what in your cloud environments. And then we're going to go into the next thing of interest is, well, how do I get things done? So the different execution environments. So there's different ways to run your Java code in these clouds. I come from not just an AWS experience. I've also used Azure in anger before. So I'll be chiming in with the Azure equivalent. I unfortunately haven't done any GCP. So, no love lost to Google, but I have to use your cloud before I can talk about it. So it's going to be mostly on AWS and Microsoft's cloud Azure. And then from there, we'll also talk about services that support your Java code. So, hey, what do I need to use for storing files? What do I need to use for messaging? What are some of the things, I need to know about for networking? So we're going to talk through just conceptually some of those high level things.
Yep. So like you said, let's dive into it. Like the very first part, right? Is essentially this concept of identity, right?
Yep.
Like if you happen to be, again, 15 years ago, 20 years ago, or I guess you used to be like, you have an LDAP server somewhere where there was like an Active Directory, whereas you sometimes try to log in some extra information, and that's how Log4j zero day happen. But usually you have like an authority inside your network that says, oh, this is Freddie. He has group access to all these folders, right? And that is where we start now in the cloud environment. If you think about the cloud environment, in AWS or Azure or Google Cloud, the very first thing is they said, like, let's set up how do you want to do the identity management for your enterprise, right? And I think that like in AWS terms, it's like what they call the IAM, as just identity and access management, if I'm not mistaken. And the idea is that this is not necessarily your logging. If you remember how LDAP does things, it's like first it recognizes that you are somebody that that has an LDAP entry. Like you identify your username and password, identifies you to LDAP. But that is almost like a gateway to what they call your group permissions, meaning like my role is a software developer role, and I have access to a database. I have access to the development servers. And all these things are not necessarily that, oh, Freddie is a new employee, I'm going to give him access to these things. It will be Freddie's a new employee. He's part of the software developer group. And suddenly I have access to everything. Nobody has to start managing like all the individual permissions that I need to have. So that sort of concept, like if somebody else comes in, let's say Mary comes in, and then Mary is a technical product manager. She has access to like all the product manager folders and product manager like software, whereas I don't have access to those. And the easiest way to manage these is by the concept of groups, right? And that is the first concept that you're going to run into AWS, where yes, if you create your own account for the very first time, you have sort of like the root access to everything on that account.
And that's what they call it, right? A root account. So you have your administrator access, but they recommend if you're going to be doing this any more than just a personal account, it's a good idea to create other accounts with reduced permissions where you're not logging in, where if somebody gets that password, is going to run up your AWS bill, right? So
somebody that's Bitcoin mining.
Will be Bitcoin mining on your account, and they're not going to have any disregard for how much money they're spending.
Oh, so that is a good point too. So let's before we dive in, I think that it is important to understand that concept of cost, because the AWS, and I don't know if they were the first, but they're definitely one of the one of the most known, that they will essentially charge you for almost just to the cent or the microcent really of how much what they call compute power are you using, right? So be this like, oh, I need to store some data. They will charge you by the, megabyte, right?
Gig.
Oh, gig. Yeah, well, they run
a lot of it's in gigs,
Yeah. How many, like, let's say, do you have a DNS entry? How many DNS entries do you have? You want static IP addresses for whatever reason. They'll charge you per month on that static IP address. And the charges are not big. There'll be like, 10 cents here, 20 cents there per hour, something like that. But then once you start looking at an infrastructure, then the thing, could be a big bill, right? And you can hear the horror stories where AWS before it's like, oh, I didn't realize I was just I was submitting a Spark job that ran like for 3 days, and somehow it spewed out 10,000 servers, and it finished in 3 days. I analyzed the work, but then my bill is $100,000, and that is another reason why splitting your root, essentially hardening your root access from the beginning, is always a good idea, especially in these environments where there is somebody who does not respect or is an adversary, could really create damage by doing all these billing things or all this charging these resources that you really didn't want them to do. So
yeah, they've fundamentally turned this into an accounting problem, whereas before it was an asset, it's fixed costs, you spend X amount of money and that's expected to last so long and eventually it gets deprecated. No, this is an accounting problem where, okay, I want to use this much. And, sometimes that's going to come out to be cheaper, especially in the small, like when I'm just getting started on a project, it's nice to be able to not have to buy a bunch of servers to just try something out. Yeah. But at scale, it's fair to say that cloud may not actually be a cost savings because you are being billed per request, where if you own it, doesn't matter how many requests necessarily come in, as long as I'm not over my bandwidth that I'm paying my internet provider.
Yeah.
And I'm paying my electric bill and things like that. It's a different model. Their model, again, is built on usage, whereas previous models were built on assets and capital investment. So
right.
Important to understand that as you're building out your cloud environment.
Yeah, and remember, like, the advantage that you have is that you have a very elastic infrastructure, meaning like Bob says, like, the bane of the existence of the e-commerce sites, when Black Friday rolls around and there's just not enough power to do everything, AWS will allow you to just, all right, I need to have twice what I used to have before, 3 clicks of a button, and then suddenly your infrastructure just go out massively.
Yeah, no, absolutely.
Right. So that's a big part of the reason that you're paying for that, right? Like, if you really want that elasticity, and the advantage is that after you're done, you said, okay, we're done with Black Friday. Let's
turn it off.
Let's turn it off, and I don't have to pay a penny more for the extra infrastructure that I was using that day.
Yep. And let's get back to what we were talking about as far as access. So Freddie talked about, we have this concept of users, we have roles of users that are assigned different permissions. And those permissions can be as fine-grained as I can read from a database, which if you're using an unstructured database in AWS, that's DynamoDB. So it's like I can give somebody a permission that says I get to read from this table and this resource in DynamoDB, and that's all that user can do. And that happens at a policy level. So, and this is also true of Azure, is you have these fine-grained policies that relate to certain actions that you can take on the cloud resources. And usually it breaks down versus, read versus write permissions, delete permissions. Can you create these resources? Can you delete the resources? Can you read them? Can you write them? Can you list out all the instances of it? And depending on your use case, you may want to set different policies. In a multi-tenant environment where I have more than one customer running code, that I'm running code for, I may not want them to be able to list out every single, VM that's running in my infrastructure. So I may not give them a list permission, but I may give them read permission with a certain naming convention. And I think that's something we might get into a little bit more when we get into our code examples. But another thing that can't be understated for cloud environments is, naming things is still a CS problem. And it is especially true in the cloud if you're going to organize it in a way that is sane. So coming up, a little bit of an aside, we could probably take another aside on cloud naming standards, but let's get into that more when we start looking at code, because then we can actually talk about pragmatically, hey, I'm going to name it this, and how does that flow through to the policies and everything like that. Right. But user roles. So users have potentially many roles. Roles are composed of potentially many policies. And those policies can be groupings of different permissions that allow specific access to cloud resources, to resources with certain names where the names match. And each of those can be rolled all the way up, to what level of access an individual has in my ecosystem. Now, another thing to kind of think about is programmatic access. So, in AWS, I can log in as myself and do things on behalf of myself, but sometimes I may want to do things within a program. So AWS also has different credentialing where I can do a secret and a key in order to associate with a specific user that has certain roles and certain policies associated with those roles. Mm-hmm. Azure has an equivalent in what they call a service principal, where again, I will generate a user with specific permissions and policies. And in return for that, I will get a key and a secret associated with that service principal. And that allows that service principal to create resources and take action in Azure on my behalf, usually, in a programmatic setting.
Right. And if you remember, this is going back to the days where there was the famous or infamous service accounts, right? Mm-hmm. Where you created, and essentially is not I log in with this account. Interactively, it's more like there is a service running that needs to do certain things, right? Mm-hmm. Maybe you as part of your role for yourself or as a developer, I have read-only access to a data store. But when I am programming, let's say a service that needs to update an inventory or do that, my service does have the read-write on that particular, database because it needs to, right? So that is a very, and it is the principle of everything, closed by default, where if you're really just starting, this is the best advice is that make it secure from the get-go. Just give permissions only to the things that need it, right? Even all the way to, once you get down into the weeds, there is also for example, permissions of firewall permissions. Can this web server reach the internet? The regular internet, can it go to google.com? And then it's you can actually set policies or saying, nope, everything is blacklisted. And then, little by little, you start adding what do you need to whitelist on that. So yes, it's, as you start creating this and probably I'll say 60% of cloud issues is usually permissions. Yeah. So there are some tricks, right? Like if you know this already and you know that this is based on roles and you can the very first thing, if something is not connecting or something says denied or it says 404 or 503, it usually means that, look, the role that you're using is not, it does not have that permission. So the very first thing that as you're thinking about it is like trying to really say like, oh, what is the role that I'm running this under, right? And the I could be you yourself, like you're interactively doing something, or it could be the I of your server, if you're running a piece of code on the cloud.
Right. And that's an important distinction. So, I mean, there's roles can be assigned to what are called execution roles. So you may have a process running. Maybe it's a function, and we'll get into execution environments next. Yep. But when that process is running, that process has authority to do things. So, I mean, when you think about how you secure environments with APIs, with third parties, you think, okay, well, I usually have a secret and I'll have a key, and that turns into a lot of different passwords to store and a lot of different authentication pieces that I have to now deal with. Well, this is where roles is really your friend, because rather than, hey, I need another password in order to connect to the database, in AWS, the RDB, the relational database service, I could actually create a policy, an execution policy that has access to read from a certain resource. So if I need to save things to that database, I'm not thinking necessarily in terms of the passwords and the credentials to log in. I set the policy on the execution service, and because it's running in the same cloud, that policy is known to the database and can authenticate me automatically, essentially. Yeah. Which also works with maybe your Docker registry, where I'm expecting to run a container in a certain environment. It happens with source code. I mean, so anything that you can imagine that you might connect to where it's like, oh boy, I need another username and password, or I have to store a secret somewhere. No, the first tool to usually reach for in that case is your execution policy, and see is there a way I can assign a policy here where this runtime can do the thing that it needs to do, and then I don't have to worry about those credentials.
Right. Like, yeah. So it is almost like, look back at the code that you're running for the cloud. If you ever needed to add like a username, a password, and hopefully you're not adding it on your configuration files. We have 3 episodes ago, we talked about.
We did. We talked about secret managers. So you should know how to do that part, but there's a better way.
Yeah. But it should be a hint. Like if this is a service that is within AWS or within the cloud, like you say, like, oh, I'm creating a username and password for my DNS or my S3 bucket, right? Like that is a strong signal that, oh, wait a minute, maybe there is something that AWS can just add to that particular execution role, and I don't have to deal with it. And my application, every time it runs, it knows already that it has access. I don't have to like identify myself with a new username or password or stuff like that. So, just keep that in mind. But going down, like we said, right? Like we're getting close to like, we're talking about execution roles and all that. And that is because like, at the end of the day, as software engineers, we want to run code. That's what we're paid for. And, we're paid to create code that has to run somewhere. And I think that is, after figuring out your login and password and that there is permissions and there's roles, the big part that we should tackle now is like, how do I run things, right? Because that's the end of the day, that's what we need to like do.
Right. And there's 100 different ways. No, there's not 100, but there are many different ways to do it. Yeah, there's many different ways to do it. And to be perfectly frank, like each one has its place. There's no one of these that you must do that we're going to say, hey, for every situation,
just do this.
Just do this. No, depending on what you're doing, one of these is probably going to fit your situation. So, I mean, let's talk about the very first one, which is the most managed of the solutions. Which is also probably the most limited, but it's the one where it's like literally like you are started in a snap because there is no infrastructure for you to set up. There's no anything, and that's functions. So in AWS, that's Lambda, and in Azure, they have something called app service functions that serves a very similar purpose.
Right. And let's before we dive into, because and I don't know if it was just AWS, but Lambdas had like a big connotation of for example streams, right? Like the actually Lambda. So to not make it confusing, there is Lambdas within the Java.
Yeah, and we've talked about those.
Yes, which is essentially a little bit like anonymous inner classes, but essentially is just a piece of code that doesn't have a. It's almost like it doesn't have a surrounding class. It's just like there's a function. Here's the function for you to do things, right? And we call that Lambda in code. Somebody got cute and say, how do we call like a program that runs in a big, infrastructure thing? Oh, because it's just a little program, we're going to call that a Lambda. And that sort of have stuck, right? They are two different things. Right now, when we're talking infrastructure, Lambda is very specific to a piece of code that you want to run, and you just really, that is really what it is. It's like, I want to run this. I don't care how it runs. I just want you to execute on this. And like Bob said, you are very, you don't, the beauty of it is you don't have to specify all these 100 things that you need to specify for running other type of code. It's almost like, look, I just need you to execute this piece of code, and once it's done, it's done. And to be interesting is that like one of the hiccups I have when I was learning Lambdas is like, how is a Lambda work for like running a shopping, like how can I make something that is useful? And the thing that sometimes people forget to tell the story is that Lambdas can be triggered by events that are happening outside of that Lambda, right? So let's go over a little bit. The very first part is Lambda is really just like we said, it's a page of code. In AWS there is essentially you can create a jar. You can create essentially package a jar that has a specific entry points for Lambda events that will execute that. Or you can do it on Python. Like some people are more comfortable doing like Lambdas on Python, and there's a couple other languages that you can do it on. But the idea is that AWS on a particular event, or and the event could be a timer. It could be something that you decide, hey, I want to run every 10 minutes or every 3 hours. It will spin up an ephemeral, meaning like it's not. It's just something that it gets created. A ephemeral like VM. Essentially standard a server, then drops a jar in, starts a Java platform, and then says like, okay, call this method because this with this parameters, because this is the event that we're responding to.
And all of this is hand wavy because again, you're not exposed to any of that. So I mean, the best way to think of Lambda, and again, I would actually argue that Azure actually has a more accurate name. It's a function, right? So function we understand as programmers, right? A function is a method that has a name that takes parameters and may have a return value for it. So, I mean, when you think of what is a Lambda function, think of it as a method, a function in your code that has parameters and has a return value optionally. So, and whatever happens in between is what you wrote. So, when Freddie's talking about triggers, those are the things that feed in the parameters to your method. They can come from multiple sources, but as long as within your method, you have a means of taking those parameters and putting them to work for you, it doesn't matter if it's coming from a message bus or an HTTP request or from a file, from an email. There's so many different things that you can use to trigger these things. Is really they end up being the glue to your cloud infrastructure. It's like, this thing almost does what I want, but I need to make it do this in a custom way. Write a function, have it do the thing, have it that feed into your function does the custom thing, you're on your merry way. So, I mean, it's really, these are integration and glue for your cloud environment. is a good way to think about it.
Like an example for just to make it more concrete, right? Like let's say that you have a provider, and this happens, this happens a lot in like the industry that I'm in, that will ship you an email with a file, right? Let's see, or they drop it on an FTP folder somewhere, right? And you want something that happens when that file gets deposited there. You want to open it up, read it, parse it, and let's say that it contains flight schedules for like your next flight, and then you take that that sort of like drop in, you open it up, you process it, and then you insert all that information into a database, right? And then now that you updated the schedules because of this new updated file that was sent to you, the Lambda will do all that. Like Lambdas sometimes they can be complex. It is recommended that you don't keep it that complex, but you're supposed to like do things like this, where it's like pick something, write into a data store, create new events. You can essentially cascade these events to other Lambdas that need to do other things. Let's say that maybe there's a Lambda that has to recompute a cache or recompute some kind of like things now that the database is updated. It's like, oh, their database was updated. Now you need to do these other things, right? So the idea is that you Lambda, and that's what like Bob says, like optionally returns a value, because sometimes you don't need to return a value. The Lambda, the function itself is doing the work that you need it to do, which is add to a data store, send an email back saying thank you, verifying that the file that was uploaded was right? All these other things, and again, if you think about it, this is really just sitting in the middle of an ecosystem. So an event came in, you woke up, you executed, and then you can either say like, I'm done because I executed and I did all my database writing or my message pipelining, all that. Or you can say like, look, now I'm going to raise a new event that maybe other Lambdas are interested in hearing about, right? Like, oh, data updated for, like flights number 1, 2, 3, right? And of course, as the Lambda executes, every cloud provider will remember how long it took to execute.
How many times it was executed.
Yeah. And we'll give you the 15-cent charge, which is for one Lambda is amazing. But if this is something that executes a lot of times during the day, then expect that Well,
and there's interesting. So it's even more complicated than that. So I mean, it also in a JVM setting, well, in actually any programming language setting, you also are able to throttle how much memory it's using. So obviously, if your process is more memory intensive, the cost per execution goes up. Because that is it is computed with, okay, you ran for this long with this much memory allocated. Mm-hmm. And there's also ways of when you think about that, it's like, okay, well, if it's just starting and materializing anywhere, and it's not warm, especially from somebody that comes from a JVM background that knows, hey, you got to kind of warm these things up before they get fast. There are certain trade-offs with your functions because it is starting from what's called a cold start. Yep. You will actually have to deal with the JVM starting up, the code, all the classes being loaded for each invocation, and the JIT being in sort of a new state where it hasn't had any cycles to run and optimize itself. So these other things you can look at is what's called provision concurrency in a AWS environment, where it will just keep certain things warm and running and just waiting for a call to come in. So, with a JVM process, there are certain things that Java is not necessarily tuned for. And that's, one of those things to start up. Now there's other things you can look at. We've talked about on the show about native compilation with Graal, which takes a lot of that startup time out of it. That's when, having a millisecond startup time for your process becomes super important.
Actually money. Yeah.
Because it involves less memory and less time. It can actually have a significant financial impact if you're running Java processes at scale as functions.
Yep. And that is true. Like one of the things that I remember like reading from AWS, like you're right. Like a lot of the times it's not, we make it sound naive, like, oh, I'm starting a new JVM every time there's a Lambda event. But yeah, the reality is a little bit more nuanced. I think by default, I think when you wake up a Lambda, it will stay up, quote unquote, up and running for like 5 or 10 minutes before saying like, okay, I spent this time waiting for other events, nothing came. Okay, I'm gonna shut it down. And I think like AWS is kind enough not to bill you for those. Like if the Lambda was not doing anything, but there are tricks, right? But yeah, actually Growl was not necessarily that was the use case, but they were very interested in like, can we create something that is very like open up, start, do it quickly, close up, right?
Yeah.
So
no, and I mean, it becomes very important because when you look at a language like Java that's really been tuned for multi-threaded environments, for longer running processes, functions are the exact opposite of that. So, if you're looking at a process where you're going to try to do really fast scale ups and things like that, Lambda does have the ability to scale. So the more load that comes in, AWS is managing how many of these things to start. But if each one of those has a cold start, there could be performance implications of using your Java process in a function. Yep. So, I mean, the function, like we said, none of these are silver bullets. The function is really nice for getting started. I can get started with just a simple jar file. I don't have to worry about a Docker container. If I want to use Docker, I can for Lambda, but I can start with a simple jar file. And that's it. I just upload the jar file and it just runs, which is pretty amazing coming from a background where you had to request a server and then install the SDK. And no, all of that's there waiting for you. You just tell it, hey, this is a Lambda. I want Java on it. This is the version of Java I want. And I upload a jar. And then all I need is stuff to come in and trigger it, which is pretty amazing. And all I'm doing is implementing, if I use just the AWS SDK, I'm implementing a simple interface. And again, it is just a method with parameters, and I can send output. I'm writing a method in Java, and I am getting something live within seconds, which is pretty amazing.
Right. I think then in terms of like the next level, right? Like again, Lambdas does have a specificity. You want something that is event driven. You want something that is small within scope. And by the way, it doesn't mean that you have one Lambda. Usually if you decided to take this kind of like software design approach, you're going to have, to create a system, you may have 10, 20, 50 Lambdas, and they all do like different parts of things. Right. But you cannot create a complete system. I mean, you can, but you may not want to. There may be use cases where a lot of those advantages you get with the Java programming language come into play. I want to be able to serve multiple requests on a warm. I want logs. Well,
but you get logs from Lambdas. Lambdas will still log. It is not hard. It is not hard.
I don't know. Like maybe
it's different because it's per instance, right? So there's we can get into the specifics of that, but I feel like that's a next episode thing. Yeah. But to just kind of seeing where you're going, if I want a longer running process, if I want a process that's going to stay up, but maybe I still don't want that experience of, geez, I need a complete server setup, that I have to patch and that I have to maintain. What's the next level up? If I want, maybe I'm starting with just a Docker container or something like that, and I want to run that. But I don't want to deal with VMs and I don't want to deal with maintenance issues. What can I go to next?
Yeah, I think is container services, right? So
yeah,
like
ECS.
ECS for AWS. I don't know what is that.
And then app services also supports a containerized environment in the Azure environment. So I mean, it has similar functionality. So we're in AWS. AWS has Docker repositories just sitting there waiting for you to use. Azure has ACR, which is the Azure Container Registry. So you have an entire registry where you can push Docker containers, and those containers, using your policies and your roles, can get deployed to app services in Azure, where I just have a Docker container, and it's going to run whatever's in that Docker container. But if I look at the screen that shows all my VMs and the things in the OS, the things that I know I'm going to have to patch and have to maintain, there's nothing to be seen because those VMs are hosted by the cloud environment. So any sort of OS maintenance, patching, I'm not thinking about that. I maintain my Docker container and my jar that runs inside of it.
Right.
That's it.
And then to go for those who like Docker is still a magic word. We did have an episode on Docker, I think, probably like 10 or 15 episodes ago. But what it is essentially, it's a combination of description, right? Where you describe like a machine that you want things to run in, right? But you describe it very loosely. It's going to be a Linux machine. You want to install this version of Linux, and you wanted it to run with this kind of like, you can sort of set the startup to say like, I want this kind of Java, and here is my jar, right? Like the beauty about containers is that it runs the same everywhere. So anything that knows how to do Docker, quote unquote, will guarantee that you are running essentially the same kind of like machine type, right? Like the same Linux type, it's exactly the same Java type that you specified on that Docker sort of like recipe that you have. It's like the Docker file, right? So the thing that you don't have control is, for example, you cannot say I wanted it to have, like 12 processors or 20 processors. I wanted it to be this class of processors. I wanted it to run like on Windows, like you're giving away some of the stuff, but what you get is that portability of like a container. It's a container on any Docker environment. So one of the things that ECS does is that, like Bob says, it's essentially, imagine there is a sea of servers somewhere on the East Coast, or on the
West Coast, maybe. I mean, that's another thing to kind of mention about these cloud providers is they have data centers everywhere. So depending on where you want a server, you kind of get to pick.
Yeah, and you can make decisions based on like, I want my data center to be close to Asia because I do a lot of business with Asia, right? But the idea is that the one thing about the cloud is that at the very end of the day, it is a physical server on a rack somewhere in the world, right? But the good thing about, like, for example, ECS is that you don't worry about that. You just a server will be picked for you, that it'll be partitioned right, and then suddenly your container is running somewhere on a server, in the middle of the world, right? The other advantages that you have is that because you did not have to worry about specifying all this, like I want 60 CPUs, I want it to be exactly 23 gigabytes, and I want it to exactly be this way. A lot of the Amazon then starts saying, okay, how many of these you need, like how many containers you need, right? Like it is like, I need 10 of them. And it figures out all that stuff. Like before, it was always this game of like Lego where you're trying to figure out, there's enough space on this particular server to put another thing in here, or no, this one cannot fit in there. Maybe we should move it to another one. Like all of that is completely disappears from your field of vision.
Yeah, I mean, there's still limitations where you're going to dictate. Well, so I have a Docker container, but I want to dictate like, what is the memory that I'm going to be allocating in ECS for this Docker container? What is the CPU shares? So I may not say, hey, give me 20 processors, but there's virtual processors that I have to allocate for my process. Right. And in true cloud form, the amount you're charged is based on how heavily you provision it. So if the more CPUs you require, the more money, the more memory you require, that money goes up even faster. Mm-hmm. And there's limits to how many you can have on a single process, but that's still a step up from functions, where in functions, you can define memory, but you're not really talking about CPU shares. So now I can actually put CPU share limits, and I actually have more control over the scaling, because like I can start at 1 and then I can go up to as many as whatever these limits are. which is another kind of cloud thing. No, even though it's like, hey, you can scale to infinity, there are usually soft and hard limits on a lot of cloud resources. So you do have to think about what the limitations. When I started using ECS, there was a limit of, I believe it was like 40 tasks per region that you're in. That's since been extended. And a lot of times these things change, but you had to take that into account that if I needed more than 40 processes in a specific region for what I was running, I had to think, okay, I got to put this in this region. I got to put this in that region. So you have to think about those things. But with an ECS, once I define a task for that, as long as that task is running, it starts up and that process runs as long as that process in the Docker container is active. So if, I get it out of memory or something like that, ECS will typically realize that and just restart it for me. So I get in this situation where, function, it calls it once and it could throw it away. It could keep it warm, like what Freddie was talking about. But with ECS, it's basically just running my Docker container using the same rules that I would be setting, if I was running Docker on a VM, where it's monitoring the process for health. I've got logs attached to it, which, is reading and write, from the console that the app is logging to.
That's the center.
I can attach load balancers and supporting services, which we'll talk about later. But that process stays up, it stays warm. I can scale it to a certain number of instances, to a certain number. So if I am, and I can even create auto scaling functionality off of that. And in all of these, again, is supported in app services in Azure as well. So I have this basically auto scale process where all I did was create a Docker container and some configuration around what I wanted that Docker container to run in. And I'm still in that situation where I don't own the VMs. I didn't have to think about how many servers to buy beforehand. And I'm paying for the running time in that case. Instead of invocations on an ECS, it's usually all about, what am I provisioning in CPU shares and memory and how long is it running?
Yep. And yeah, to bring also a couple of things. Like usually, like ECS will also give you access to, like, for example, file systems, right? Like Docker's usually will come with a little bit of a file system, and I think like by default it's like 5 gig on AWS, and which is like it allows you to do certain things. That was one of the things that I remember running into Landis. Is like, oh, I need to write a file. Oh, there's no file where I can write, right? Like it becomes weird if you need to like do certain things, because it is a method that disappears at the end of it. With ECS, you start getting a little bit back on those things where there is a file system. It is interesting because on the AWS world, there is two kinds of ECS. One of them is called ECS on EC2, and the other one is called ECS on Fargate.
Yep.
Right, and I think I think we might need to do a roundabout trip up to go back to ECS and EC2 after going over the VM. Yep. But the one thing is like especially because as a decision point, ECS and Fargate, you will not have access to your container, your running container, through the command line. Like that is something that
like a Docker execute where I get to log to a bash shell or something like that. Right.
Yeah. Right. Like and they do it for security. So for security, because like what happens is by default ECS and Fargate, you're running Docker. You don't know who your neighbor is. Like you can be running on a big machine that is running 100 Docker containers. One of them is yours. 99 others are from other people. So what happens is that AWS said, like, look, we can give you the standard output of your Docker container. We can give you all this stuff. We can give you metrics, but you don't have the ability to quote unquote log into your running container, which is something that if you've been using Docker for a long time, sometimes you tend to do that just to see like, oh, did I mess up some of my recipe, or did I do something wrong? Or I want to see inside troubleshooting, like getting a heap dump or something and then trying to get it out.
That's one of the fun things about app services in Azure is they actually do provide an SSH like web console. If you ever go in and play around with them, so that you can actually get a command prompt inside of your Docker container. Nice. one of the differences, conceptually, it's the same thing. You're not seeing the VMs. You don't get SSH access to the host machine. Where if you're trying to figure out, hey, is something broken on the host machine, you're not going to be able to do that. But as far as the Docker container and app services, there is like a command line console. There's still access to logs and other things to debug. But I mean, as a Java developer that's used to running jar files, functions provide a really cool, fast way to get started. But as far as, hey, I'm used to running apps, ECS is a good negotiation, a good middle ground between, all right, I don't really want to own the hardware, but I also want to run like an actual, long running application. So it has its space in between the completely managed functions and then the little bit more of the ownership, which is, I feel like, what we're leading into next.
Yes. And let's say that you are very picky about like exactly how you want your environment to be, right? And there are cases where that is. I found it that if you are very CPU bound, or you have like big memory requirements, you might bust out of like something that AWS like ECS manages or that Azure manages. Like, they're like, oh, up to 16 gigs, super easy. Maybe there's something they can do. But once you start getting beyond certain size, both on CPU and on memory, they'll say like, no, you need your own virtual machine that you can say like, I want this much. And you can configure it. The other things that you can do is you can configure it the way you want it, right? You start getting into, okay, I don't need this Docker image, but I want this particular Red Hat version of Linux, or I want this particular, CentOS version of Linux, or all these, or Windows machines too, because we have to use those too. Like you get now into, I want to create a machine, a server, or a server machine with this particular operating system, with this particular metrics, with this particular memory and CPU requirements.
Yep.
And that's where it comes to like in AWS it's called EC2. I think it's the Elastic Computing version 2. I don't know what Azure calls it.
Yeah, Azure, I think it's just basically called VMs. So I mean, it's conceptually the same thing. But yeah, but you're not waiting like 3 months for that custom machine to get on, a box and then, get on and come out. So, I mean, the beauty of it is, and it even goes beyond just like CPU and OS, like I want a GPU. They've now gotten to the point where, if I want custom hardware, I can get it. If I want SSDs instead of spinny disks, or, elastic storage that's going to get mounted in an S3 bucket, or not an S3 bucket, but like their virtual file store, VFS. I can do that type of customization. Oh, yeah.
Like the network too. Yeah.
The networking, I can say, I want this many NIC cards, so I can do a lot of things that is almost a custom order. But when I'm done with it, I can just say, turn it off, and I'm not charged. So, I mean, the VM pricing model is very similar to the ECS pricing model, except with a lot more flexibility. So, what both of the services look at is, okay, if you want high CPU and high memory and you have a high spec machine, your basically hourly rate or per second rate, whatever the multiples that they do it in, is higher the more souped up you are. But if you have a really basic machine, you can get away with, fractions of a cent, per minute. So you're, or per hour, I think is usually what most of them have it in. But, depending on what your specs are, you have on-demand compute power from either the Azure VM service or the EC2 service from AWS. And again, this is where I finally get an SSH access in both of them to the host machine. Now, well, not the host machine, because these VMs can be running in virtualization. I'm not getting bare metal hardware. Although I believe AWS has a bare metal option, so that you can actually get bare metal on AWS in certain instances.
And it's worth expanding a little bit on this. Starting circa 2008 or 2010, everything is virtualized. So what that means is like, and I still remember the big deal with the hypervisors, and I remember what was it, VMware was super deep into it. What happened was that chip makers started figuring out how can they run quote unquote different environments without having to pay a, like usually you can always do it, but it usually had like a CPU penalty every time you did that. But it's starting, whenever like Intel introduced hypervisor and AMD follows suit quickly, what happened is that the chip makers created sort of like these instruction sets that makes it super easy or super cheap to run multiple virtual machines on the same CPU. And what then is like essentially took all the world by storm. And that's why like the cloud providers, we said like, you don't know if you're ever running on a physical machine anymore. Because if I gonna made a bet on that, I'll say like I'm probably just virtualized somewhere, right? Because like that gives incredible flexibility for data centers to say, look, I'm just gonna upgrade all these things. I'm gonna give them twice the memory, and as soon as I put them in, then I have double capacity to have more EC2 machines, just because now there's more space for them to be in there, right? So it is something to like consider, like, and this comes into play not necessarily a lot, but if you are doing something that you really say like, gosh, I need CPU affinity, right? I need like this type of hardware affinity because I'm gonna do tricks.
To do things in the kernel. Yeah.
Like what, like, just be in mind, like, and again, for 99.9% of software out there is a non-issue. But for that 0.01% where like, no, I ain't gonna life burn this core by having a white lock on that thread that I needed to be the fastest thing. And I think I'm talking about like trading is the first one that comes into mind.
Yeah, I mean, because there's so many things to tune, right? So, I mean, where a lot of these services, when you look at ECS and functions, which we talked about before, one of them you're paying per invocation, the other one you're paying on time, but those installations, you can't tune the connection counts coming into them. I don't have control of the host machine. Once I get to the VM, I can tune the kernel to optimize connections. I can tune to optimize how I want to utilize the memory on the host, permissions, ports, all of that's on the table. I have SSH access. I have a fully provisioned virtual machine that I can do what I need to do on. And if I want to put Docker on it and do my own, ECS on that, I can do that. So it's really opens the door to those custom solutions and really things that may not be economical in those other areas because the default settings maybe don't fit what I'm trying to do.
Right. No, and that was the other part. Once you start getting into like provisioning your own VMs, you start getting into, you open essentially the door to, like, for example, like Chef. You start getting some kind of like infrastructure management. Where, for those who don't know, like Chef and Sync, I guess, is the open source version of it. It's a way for managing machines, right? Like at the very beginning, the way it worked, it was like somebody will get a black box delivered into a data center somewhere, and a person had to sit in and click next while they install Windows 2000. And then after that, they have like this big long laundry list of, oh, now it needs this drivers, now it needs this services, and now they need SQL Server. A lot of that got automated out, with the big DevOps movement, where essentially it's a little bit of like, I guess, provisioning as code. Well, it's not quite provisioning as, it is provisioning as code.
Yeah, that's probably what I would call it too.
Yeah, like where you said like, look, on this new machine, I want you to, install SQL Server. I want you to install these things. I want you to open the firewall this way. And essentially you create, Chef recipe, what's called Chef recipes, that gives you all that. So if you're really thinking that you want to go the VM route, like, say like, look, I want to have some authority on, on these things, and it's really important to you, then do consider that you probably want then than some kind of like provision managed software to help you manage that infrastructure. Because like we said, like we're going from the most restrictive, but the one that you don't think about anything, to now you are working on a machine, and one virtual machine you can set up manually, two virtual machines you can set up manually. You need to suddenly provision 100 once because there's a big, thundery hair problem. You cannot do that manually. You probably want to have some, and that's, you have the freedom. So now you have the responsibility of figuring out how to.
And it's not just about scale. It's also about security. So you're owning security patching now. So when that AWS and Azure are not going to upgrade that OS for you once a vulnerability comes out, that's on you once it's a VM.
Yep.
So, they're not going to secure the ports for you. I mean, there's different policies I can attach in order to block things at a network level using some of the supporting services, what we'll be getting into next. But I've got to set that up. They're not managing it for me as they are on functions and ECS.
Right. And the last part on this, what I was going to say is like, so just going back to the ECS example, which is like what is called EC2 on ECS. And this is a eternal confusion terms. So I want to spend the extra time. I may even throw in like a little like diagram in it. But the idea is that, now that you know that ECS is about running Docker containers, we said like AWS have two choices. The first one to run these containers of ECS is in Fargate, which is completely managed by AWS. This is where you don't have access to running things on the shell and stuff like that. But on the other hand, like you don't manage any of that infrastructure, right? But the other choice that you have is like, let's say, look, I still want to have control on how like my Docker ecosystem works, right? And I want to say like, look, I want to, provision this kind of machines to run Docker containers, right? So then what you can do is what is called ECS on EC2, which is you create your cluster of machines, you set it up the way you want it on EC2, you create your virtual machines, you say, this is what I want. And then these are essentially then the machines that are going to be essentially the platform where your Docker containers that you're provisioning through ECS will run. So every time you create a new, and I think AWS is called tasks. When you create a new tasks, you sort of say like, where do you want to run this task on the ECS Fargate, or you want to run it on the ECS on, and you create your clusters. You say, no, I don't want it on Fargate. I want it on my EC2 cluster that, I set up just the way I want it for Docker containers, right? So it's almost like a little bit of mix where you do have usually to provision big virtual VMs for it, but then once you provision those, you can run all the containers you want, or that you want to do it, right? So it gives you the ability to then troubleshoot what's going on in the containers. Like Amazon will let you essentially run Docker exec on things that are running within your own cloud, right? Like with your own EC2 server or virtual machine servers.
Yep. Yeah. And then if you want to scale up even more and use Kubernetes, both Azure and AWS provide managed Kubernetes services where it's kind of the other way around, where it's managing the Kubernetes side for you. So it's a little bit of the combination of, well, I have VMs, but I'm not directly managing them. They're kind of saying I'm kind of giving either AWS or Azure a spec of what kind of servers I want to put in the pool, and then they're building that out in scale so that I just have to worry about, okay, I just want to deploy my Helm charts or my YAML files in order to get Kubernetes to do what I want it to do.
Yeah, no, and that is like, I think that is the other, like Kubernetes is, we probably have another episode.
Yeah, we're not going to get into Kubernetes today, but it's worth mentioning that, it's not just the micro to macro scale. That's on the far end of that.
Yeah, no, that's like, I'm thinking like, oh my gosh, there is so much, right? Like, yeah, from Helm and how it does all the stuff, but we'll put it as an IOU. Like, we'll come
future back show, but we should talk about the supporting services before we close up, because the execution environment is just one piece of it. That's what's running my code, but there's a lot of things that go into supporting those things. So, one example is I have an ECS cluster or I have a VM cluster, and they're all running the same instances. How do I route traffic equally between those instances? Don't I need networking infrastructure to make that work?
Yeah. That's where we go to the load balancing aspect. And this is it took me a while to understand like a little bit of the DevOps. Like we were, I think, all the way from the 19s to like 2008, it was, like there were developers and there were operations, and developers just like shove some code over the wall and operations figure out how to run it. I think after that, you start getting appreciation of like, oh my gosh, there's a lot of stuff to do, right? And the thing is, like, we always think about clusters and hundreds of machines running.
Auto scaling.
Yeah, it's like a magic, right? Like, but if you think about the operational construct of how does that happen, right? Like, for example, one of the things that usually happens, like, is that you have this router in front of it that decides to balance the load and say, like, there's a request and I have 100 servers. Okay, this request is going to go to server 1, and this request is going to go to server 2, and this request is going to go to server 3, right? And so you need to have sort of like this kind of router in front of it that it may like, and depending on how you set it up, it may need to keep like that connection. So meaning, like, if it's a long session, this like, oh, I remember you were connected to server 1, so let's
affinity.
Yeah, right. Like there's server affinity for requests, like, and all these other things, right? So if we're on the 2000 days, then somebody needs to create that, and somebody needs to say, tell me what are the servers that are registered to this particular router, right? Oh, I created a new server over there. Then usually the operations guy will say, well, give me the IP address of that server, give me the address, and then I can put it up in rotation, right? So a lot of the complications that sometimes if you're never being exposed to the cloud and you're exposed to it's like, why do I have to set up these things? A lot of it is because, like now you're getting exposed to the upside, which is, once you understand how it works, it's amazing. But because we never had thought about it, we think we always feel it like it's so weird. Like and the first concept, like on AWS, is called target groups, right? Every time you create a new instance, or you create quote unquote a cluster or stuff like that, or ECS, usually there is a target group that identifies those tasks. And what the target group is doing is like saying, look, this family of servers is for my shopping cart. This family of servers over here, this Docker containers here is for my, like batch processing backlog. So you sort of start splitting up if you think about your infrastructure, there is servers for things that I need them to scale this way. There are servers that I need to scale for this other microservice, especially microservice architecture, where you can have different little services running on different little VMs doing many little different things, right? So, but the thing is, like, once you have that target group, the target group is then now responsible of saying, like, okay, are these servers healthy? And that is something like usually you start seeing this is an ops thing where I want to know if that particular server is working the right way or not, right? And there's the need to have like health endpoints where it tells, like, oh, the server goes, usually the easiest way that most people will do it is like, can I pull up a web page, right? Like you give it a URL, it goes to that server, pulls up that web page, it returns to 100, that means the server is in good health, returns 500, it means that server is bad. And then the fun part is that once you start having those kinds of things built in, then the target group with the load balancer can start doing things like, look, that instance reported that is bad. Let's just kill it and create another one over here, and register it with the target group. So the load balancer knows like where it needs to route traffic. And all these things happen behind, like you never seen it. Like that is the fun part about it. Like if you, for example, the other thing that you could say is, for example, look, I want to auto scale when my CPU is the average CPU of my target group, it hits like 60% or 70%, right? Or when the memory that my target group is using is at 70%, right? There's many dimensions where you can say, do you want to scale? But then the target, the load balancer with the target group is in charge of monitoring and say like, oh, we're getting close to 70%. Let's spin up more instances. And you tell it how do you want it to scale up, you tell it how do you want to scale down, but all these things are essentially part of the target group / elastic load balancers that like for example, AWS provides. And I'm sure that Azure has exactly the same.
Yeah, I mean, you can basically replace target group with backend pool, and conceptually everything you're talking about is the same. So I mean, they just have a different terminology, but as far as load balancing, application load balancers do have all the health checks and draining rules and all sorts of things that, again, as an application developer, you probably never thought of, but somebody was handling for you when you were in your on-prem configuration, right?
Days of 2000s,
now you get to do that yourself, or you just have to understand, what are the different kind of toggles to go. And most modern app frameworks are coming with health check endpoints. So it's like, a lot of this you don't have to build. It's just a matter of picking, a modern framework and enabling the correct things. And then, a lot of this load balancer interactivity just kind of works.
Right. And that is the big thing. Like, for example, to tie it back, like if you're using like Spring, if you do Spring Cloud, the actuator will have Spring, it will expose an endpoint called like /actuator/health, right? And it will, and it's, by default, it will almost like auto configure depending on the things that you have. If you say you have a database, you use Spring Data and you use the database, it'll try to figure out if the database connection is healthy. If you're using like, some kind of like metrics management, it'll try to figure out that it's running fine. If you're using something like Redis, it'll try to figure out is my Redis or my, working the way it's supposed to. But the idea is that you do take those endpoints and you start updating them with things that are maybe more closer to your application. If there's things that you are watching, like you create socket connections to something and need to monitor that those socket connections are still fine, right? And that's part of your health check, right? It's always, it's always being asked for. And if you never knew why do I need to create this programmatic health check instead of going to a console and looking at things, the reason is because of that. Because all these, once you have a health check, there's load balancers that then can make sure that, oh, that thing is unhealthy, it's non-responsive because it run out of memory, right? Like it can just kill it out and create a new one, and you don't have to be on that 3 a.m. call saying like, hey, a server died, and why did it die?
Yep. And I think the other thing is leading in, once you have a load balancer, there's also conceptually, you want to create a domain name that allows people from the outside to find it, or even if you're doing internal networking, just being able to have a more sane way of routing your services. Most of these services, when you create a VM, when you create a load balancer, it's going to give it a domain name, but it's going to be very specific to the cloud you're using, and it's going to mean something in that cloud. If I want to get back to connecting to the outside world again, AWS and Azure both have DNS services that can help facilitate that. So Route 53 on the AWS side, where I can basically just create DNS entries, either for internal DNS or external DNS. And within Azure, you also have a DNS service in order to do a very similar thing.
Right. And if you think about it, right, like that is a progression, right? You first created your code, you created your jar, you figure out how to deploy it. Let's say that we decided Docker on ECS. Then you sort of like define the target group by task, and then you have the load balancer. The load balancer will give you this long name, AWS specific. And then suddenly the last thing you need to do is like you go to Route 53, which manages your domain names, and you add, say like, oh, I want this domain name to point to this target, to this load balancer. So then when the name resolves, the very first thing it's going to go is going to Route 53. Oh, my 8 record, which is essentially the record for most of our most of the stuff that we usually do to try to get to is just like, oh, it needs to go to that particular load balancer. It gets to that load balancer. It's like, oh, I have 50 Docker tasks running. I'm going to pick this one, and then it's going to shoot it all the way over there. So, you get that access all the way from the outside to the inside. And the good thing is that you can protect each step of the way, meaning like AWS and Azure are very good at saying, look, it's not like your server is sitting out there unless you specifically said that. Most of the time, it's just going to be like what is called natted. So like you will never know. Like you get essentially, I think AWS have like a very small family of IPs that are public, and then but they will never know that you are hitting that particular cloud container running on your private cloud or on your particular cloud account, and it's going through all this magic. So the fun part is that this is actually hard work if you were gonna do this in an ops way, right? Like if you actually wanted to do exactly the same thing, where you have a DNS, you want to create that isolation, you wanted to create that scalability, create those routers that scale up or down and have that infrastructure. If you were going to replicate all of that locally, like saying like, I don't care about clouds, I just want to create my own AWS, it's very, very, very hard. So that is essentially why they had the adoption that they had, because people really don't want to manage all these things. They'd rather just somebody else manage and just pay for the ability for not worrying about it, right? And as a DevOps people, because like now the movement is DevOps, sometimes it's it was interesting that mental shift where at the beginning, if a DNS entry didn't work, I will just pick up the phone back when we had phones before Slack, and call the ops guy, or it's like, hey, something's going on with the DNS entry, can you look at it? And then that, because I did not have access, right? Like as a developer, we usually never had access to DNS servers, and an ops person will say like, you're number 350 on the list, you wait until next week to get that DNS fix. Now, because of if you're working on a cloud, chances are that you may have more range of looking at what things are happening that you think, and a lot of it is because of this DevOps. And the good part about it though is like even though we've been going through a lot of things, and I know it sounds complicated, each one of them individually do make sense. This allows you to troubleshoot. Like for example, the biggest thing that sometimes happens is like I go to www.mything.com and it never comes up, and you're like, what could be wrong, right? Now you sort of know that you start by you can start on the out layer saying like, oh, do I have a Route 53 entry? And usually when you have a developer AWS console, most people will at least allow you read access to see what's what, right? And then when you go to Route 53, you find the record, oh, looks right, it's pointing to this particular load balancer. Then you can go to the load balancer. It's usually on the EC2 for AWS. And there's a load balancer section. You find the load balancer and figure out, is this the right target group? You go to the target group, and then is the definition of the target group right? Is the health check pointed to the right place? Maybe it's pointing to the wrong port, or pointing to the things that are not quite correctly. And then you can keep going down. And it's like, oh, okay, it's going to the right place. And you go to like, oh, it's going to my ECS instance and the task. And then you look at the task, and the task never started, or it's always in an infinite loop. You can now troubleshoot these things, because like we said, it's even though it's a lot, if you just look at it like pieces of Lego,
it's visibility, right? So the amount of self-service also gives deep visibility into the entire infrastructure, to the point that developers have never had that, because the ops team doesn't build those type of dashboards, because it costs a lot of development time to build that out. AWS, Azure, these cloud services, they've already built these things. So it's just a matter of scale. So, I mean, you get the scale of these larger companies that have built these large data centers that are built to scale without having to learn all the lessons of scale yourself. You can kind of take advantage of it. And that's one of the biggest things, so if you, and they've added all of these supporting services for networking. I'm just going to list off a few of them because I think we're running a little short on time, but they all have pub sub models. So between SNS and SQS and AWS and message bus in Azure, you don't have to set up an MQ service anymore by yourself if you don't want one.
Yeah.
The other thing, like for for storage, you have S3 where you have basically extremely large file storage that can be available and access controlled in AWS. In Azure, you have blob storage. You have a number of features that give file storage where you're sitting on a VM or you're sitting in a file directory where you run out of room. And now it's like, okay, now you got to buy a new disk. No, these are elastic systems. You got to pay for how much you put on there. But the scale problem is sort of, not something you have to think about. Somebody else is taking care of that. So having the visibility, having the options and supporting services to say, hey, I'm not an expert in MQ, but maybe I can just spin up this service and play around with the SDK and see how it works. And that's essentially what we're hoping to do with you guys next week, when we kind of do a little bit more of a deep dive into creating the cloud infrastructure through the SDKs.
A toy project that
I think so. I mean, I think that, we're going to show different ways of programmatically working with it. But hopefully this episode has given you kind of that high level where it's like, how do I think about this? What are the different things that I need to be considering when I'm picking which thing to use in the cloud? Because there's usually 100 different ways to do it. And there's not one right way, but there's probably one way that's a little bit more right.
Yeah. And just to reiterate that part is the fun part, when it comes to all these visibility is that instead of waiting, 2 weeks for somebody to look at the ticket of why DNS doesn't work, you can just go in the next 5 minutes and see like, oh yeah, this looks wrong. I know exactly what it is. And sometimes, if you have enough permissions, then you can just fix it yourself. Other times, there'll be like, maybe you have only read-only access, but you can just tell your ops teams like, look, I see that the DNS entry is wrong, or I see that the load balancer has the wrong target group or the wrong health check. Can you just fix this? And suddenly, instead of 3 weeks of figuring out what it is, it takes you in less than a day to like, oh, I got it. This is easy. They can just do it. And that is the huge value. Like, once you start getting into some of the ops part, for me, like the big thing is like, I don't have to wait for anyone. We can just go in, we can figure it out. We can self-serve, part of the benefits of having that responsibility, right? So,
yep. You control your own destiny, but you also control your own destiny. So, there's no one to blame when it goes wrong.
Okay.
We're hoping to guide you through that. So hopefully you got a lot out of this episode. I know there's a ton more material to cover, but I hope that gave you a good overview of at least two of the clouds and the core concepts around them.
Yeah, no, and for those of you being avid listeners, happy 100 episode, right? And if you just jump in, these are considered like, even if you're a latecomer, even the first episodes, like of PubHouse, they are mostly evergreen. Meaning like they are things that apply throughout. Like our first episodes were very going deep into like the weeds of like just core Java programming. And we sort of started branching out more of like the libraries and stuff. But, again, if you're a latecomer, you haven't heard 100 episodes yet, go back and put it on your commute. Like I guarantee you that the more that you listen to this, it's, the better engineer that you can be, because, again, we cover things soup to nuts. We try to make it, demystify a lot of like the things that happen. Remember, like I always like to say to like my junior developers, there's no magic in programming. A computer is dumb. It will do exactly as you tell them. A lot of it is just understanding what is happening behind the scenes. And hopefully, 200 more episodes, right?
Yeah, 200 more episodes. And yeah, you don't have to start at episode 1 to understand. Again, this has always been targeted for the beginner audience, the folks that haven't maybe dealt with cloud should be able to hopefully listen to this episode. And if you haven't dealt with Java and you came in because you saw cloud and you're interested in Java, definitely go back. We've got a ton of stuff. And we're going to get into more Java next episode. So don't think like we bailed on that.
We got you. All right. That's it for this episode. Happy programming. Happy 100. Take care.
All right. Bye, everybody.